Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, in this video we are going to study about thermistor. We will study its principle of working, construction, its characteristics and then its applications. So let us start with our topic. Thermistor, it is the contraction of the term thermal resistor. So we can say that it is made of two terms, thermal plus resistor. So we can say that thermistor, it is a special type of resistor whose resistance changes with the change in the temperature. So thermistor will be a material, it is made up of a material whose resistance is going to change with the change in temperature. So with the help of thermistor, we can measure the variations in the temperature. We will measure the change in resistance, and change in resistance is proportional to the change in temperature. Now, if we know here that it is made up of two terms, thermal and resistor, and if we define a resistor, it is the property of a material to oppose the flow of current through it. Okay, so it opposes the flow of current. So in a conductor, when temperature is increased, okay, so when temperature is increased, the flow of electrons in a conductor, it increases, and due to the increase in flow of electrons, the flow of current also increases. So we can say that the resistance decreases. So here we have seen that in a conductor, when temperature increases, resistance decreases. Now it may be possible that with the change in temperature, when the temperature increases, the resistance also increases. So the materials in which the temperature or in which the resistance increases with the increasing temperature, they are supposed to have a positive temperature coefficient. Whereas the materials in which the resistance decreases with the increase in temperature, they are supposed to have a negative temperature coefficient. Now most of the metals, they are having positive temperature coefficient, and the resistance detectors, or we can say the resistance thermometers, the RTD, they use the material which are having the positive temperature coefficient, whereas the thermistors, they use the material which are having negative temperature coefficient. Mostly the semiconductors, they are having negative temperature coefficient. So semiconductors are used for the construction of thermistor, whereas the positive temperature coefficient materials like metals and platinum, they are used for the construction of the resistance thermometer, resistance temperature detectors. So thermistor, they work on the principle that the resistance, it decreases with the increase in temperature. They are having a negative temperature coefficient of resistance. Okay. Now this change in resistance, it will be so small that with every 1 degree Celsius rise in temperature, so it means that the thermistors, they are highly sensitive, and because for every 1 degree rise in temperature, the resistance is decreasing at the rate of 5%. So these thermistors, they can be used for precision measurements. So they are widely used for the precision temperature measurements, control and compensation, because they are highly sensitive elements having very high negative temperature coefficient. Now if we talk about the range over which the thermistors can be used, the temperature range, the thermistors, they can be used for the temperature range from minus 60 degrees Celsius to 15 degree Celsius. So here you can see that in the negative temperature range also the thermistors can be used. Also the resistance of the thermometers of these thermistors, it is in the range 0.5 ohms to 0.75 ohms. So this is the value of the resistance of the material which is which the thermistor is made up of. Now, as I've said that the thermistors, they are very sensitive elements, but there is a drawback for the thermistors, that they depicts a non-linear characteristics. In the case of the resistance thermometers or RTD and thermocouples, the material, it has a linear characteristic, means the resistance and temperature, they are having a linear relationship with each other. But in the thermistors, it has non-linear characteristics, so that is the drawback. But it has the advantage that they are the highly sensitive elements with respect to the RTDs and the thermocouples. Now let us see the construction of the thermistors. Thermistors, they are made up of the materials which are having the negative temperature coefficient, generally the semiconductors like manganese, nickel, cobalt, copper, iron and so they are made up of generally the semiconductor materials and also the metallic oxides of the metals like manganese, nickel, cobalt, copper, iron and uranium. Now the thermistors, they are available in various sizes and shapes. And according to their shape, there are various types of thermistors. They may be in the form of beads, in the form of rods, or in the form of discs. Okay, so there are different shapes in which the thermistors are available. Let us see the diagram of the thermistors in these various shapes. So these are the four types in which the thermistors are available. One is the bead type. This is the glass coated bead type thermistor. This is the probe type. This is disc type, and this is the rod type. Okay. Now, what is the difference between these these four types of thermistors? The thermistor which are in the shape of bead, they are the smallest in the size. The bead is having a diameter of 0.015 mm to 1.25 mm. Now, the sides of this bead, they may be sealed in a glass envelope. So you have seen in the diagram that over the bead we are having the glass coating so as to protect the thermistor material. About the glass probes type of thermistors, their diameter is 2.5 mm and their length varies from 6 mm to 50 mm. Then we have the disc type of thermistors. Now, disc-shaped thermistors, they are made by pressing the material under high pressure. So, they are shaped into a cylindrical flat shape with the diameter ranging from 2.5 mm to 25 mm. So, you have seen that in these types of thermistors, the bead type of thermistor, they are the smallest one. So this was all about the construction of the thermistor, that of what material the thermistors are made up of and in what size and shapes the thermistors are made. Now let us come to the characteristics of the thermistors. There are three types of characteristics of the thermistor. First is the resistance temperature characteristics. Second is the voltage current characteristics. And third is the current and time characteristics. Okay, so there are three types of characteristics of the thermistors. Let us first study the first type of characteristics, resistance temperature characteristic. Now we know that the thermistors, they are having the negative temperature coefficient. So as their temperature increases, their resistance decreases. Okay. Also, the relationship between the resistance and temperature of the thermistors, there is a non-linear relationship between them. If we see the graph for the characteristics of the thermistor, you can see that as the temperature increases, the resistance decreases. Okay, so this shows that the relationship between the resistance and temperature of a thermistor, it is a non-linear relationship. You can see that exponentially the resistance is decreasing. Okay, now if for the same range, that is from -100 to 400 degrees Celsius, if we see the characteristics of the platinum, it will be like this. Somewhat linear relationship is there. This is for the platinum, which is generally used for the construction of RTDs and thermocouples. So from this characteristics, you can see that platinum is having a positive temperature coefficient. With the increasing temperature, its resistance is also increasing. But thermistor, it is having negative temperature coefficient. With the increase in temperature, its resistance is decreasing. Also, you can see that the fall in the resistance or the decrease in the resistance is in the range from here, it is 10 raised to the power 5, and this is approximately here 10 raised to the power minus 2. So in this range from -100 to 400 degrees Celsius, the decrease in the resistance, it is of the order 10 raised to the power 3. But here the change in the resistance in this range for the platinum is only by a factor of 10. Earlier it is 10 raised to the power -8, and then it reaches to 10 raised to the power -7 value. Okay, so here platinum is showing a very less change in the resistance for this wide range of temperature, but thermistor, it is showing a very good amount of change in the resistance for this temperature changes. So you can see that the thermistors, they are highly sensitive as compared to the platinum, which is used for the construction of RTDs and thermocouples. Now, as there is a non-linear relationship between the resistance and the temperature of the thermistor, so let's see that how this resistance and the temperature characteristics, they are defined. So the mathematical relationship or the mathematical expression for the relationship between the resistance of a thermistor and the temperature is RT1 equals to RT2 exponential beta 1 by T1 minus 1 by T2, where RT1 is the resistance of the thermistor at temperature T1, RT2 is the resistance of the thermistor at temperature T2. So T1 and T2, these are the temperatures. T1 is the initial temperature and T2 is the final temperature. So temperature is changed from T1 to T2 degrees Celsius, and the change in the resistance is RT1 and RT2 at these temperatures. Now beta, it is a constant which is whose value depend upon the material of the thermistor, and typically its value ranges from 3500 to 4500. Okay, so in this range we are having the value of this beta constant, and this expression defines the relationship between the resistance and the temperature. So you can see here that we are having a non-linear relationship here, but for this non-linear relationship, a linear approximation can also be done, just like in the case of the resistance temperature detectors RTD and the thermocouples. So we can reduce this non-linear relationship into a linear relationship by doing linear approximation. So these are the first, that is the resistance temperature characteristics of the thermistors. Now come to the second type of characteristics, voltage, current. So when we see the characteristics between the voltage and the current of the thermistor, we see here that the voltage, it's going to drop across the thermistor with the increase in the current. As the current increases, the voltage first increases, after that it starts decreasing. Okay, so what is the reason behind this? When the temperature is increased to a level, this temperature is not so enough that it is going to produce the heat in the thermistor, okay, or it is going to produce the change in the resistance in the thermistor. Now after reaching to a certain ambient temperature, the resistance, it start decreasing in the case of thermistors. So in these characteristics, you have seen that when we are increasing the current for a small value, means as the current is increased, the voltage is increasing with the current. But this increase in voltage and increase in current is not sufficient to produce the change in temperature in the thermistors. Okay, no heat is produced. But when after the peak value is reached, after that the current or the voltage, it starts decreasing with the increase in the current. Okay, so we can say that earlier we are having a linear relationship, after that we are having a non-linear relationship between the voltage and current. So the voltage drop across a thermistor, it increases with the increasing current until it reaches a peak value, which is the ambient temperature. So in this range, it is following the Ohm's law. According to Ohm's law, V is proportional to I. So for a constant resistance, the voltage and current, they are showing the linear relationship in this range. Now when it has reached this peak value, after that the voltage drop, it starts decreasing with the increasing current. And in this range, we can say that the thermistor is showing the negative resistance characteristics. Why? Because after this ambient temperature, that much amount of heat has been produced in thermistor, which is reducing the resistance value, okay, or reducing the resistance value, and the flow of current has been increased in that, okay. So current is increasing, but voltage is decreasing with the increase in current. So these are the voltage and current characteristics of the thermistor. Next characteristics are the current and time characteristics. If we see the graph for the current time characteristics, so through this current time characteristics, you can see that it is showing that the time delay, that as the time is increasing here, the current is also getting a constant value, but this current, this amount of current, it can be decreased by decreasing the voltage values here, okay. So from the graph you can see that the time delay to reach the maximum value of the current, it is a function of the applied voltage. When we are decreasing the voltage, the time delay is also decreasing, okay. So here, why this happens? So when the heating effect of the thermistor, it affects that when we are increasing the current, the voltage was also increasing. Now when it has reached the temperature value, after that heating effect occurs, and a certain finite time is required for the thermistor to heat up and start decreasing the voltage, okay. So that is called the time delay. So here we have seen that this time delay to reach the maximum current value, it is a function of the applied voltage, okay. When we are decreasing voltage, the time taken to reach this maximum current is also decreased, okay. So these are the three types of characteristics of the thermistor: resistance temperature characteristics, voltage current characteristics, and current time characteristics. Now let us see some of the applications of thermistors. The first application of thermistor, that is the measurement of temperature. Let's see the circuit for this, that how the temperature can be measured with the thermistor. Now we know that thermistor is having a negative temperature coefficient. Its resistance decreases with the increase in temperature. So resistance is decreasing. It means that the flow of the current is increasing. So thermistor, when it is connected with a battery and a microammeter, it can be used for the measurement of temperature. As the temperature increases, its resistance is going to decrease. So as the resistance decreases, the current increases. So when it is connected in this circuit, temperature is increased, current is going to increase, and this current is going to be indicated by the microammeter. So this microammeter, it can be directly calibrated so that the change in current directly gives us the value of the change in the temperature, because as the temperature increases, the amount of current flowing in the circuit, that also increases. So in this way, the thermistors, they can be used for the measurement of temperature. Also, not only for the measurement of temperature but also for the control of temperature, thermistors can be used. For this application, the thermistors, they are used along with the relays. So here, for the control of temperature, thermistors and relays are used. This microammeter, it is replaced by a relay circuit. Okay. So whenever the temperature is increasing beyond a certain range, the relay is going to get activated and it is going to cut off the supply of current to the other instruments or to the other devices connected in the circuit. So in this way, control of temperature, for that also thermistors can be used. And another application is the temperature compensation. So as the thermistors, they are having the negative temperature coefficient which is present in the semiconductor materials. So for the compensation of temperature, they can also be used. The disc type of thermistors, they are mostly used for this purpose. Okay. If we talk about the other applications of thermistors, then not only the temperature but also other parameters like power can also be measured. Thermal conductivity can be measured. Measurement of level, flow and pressure of the liquids can be done. Vacuum measurements can also be done. And for providing the time delay also. So these are some of the applications of the thermistors, that not only the temperature but also other physical quantities can also be measured with the help of thermistors. Now let us come to the advantages and disadvantages of thermistors. If we talk about its disadvantage, its only disadvantage is that it is having a non-linear characteristics between the resistance and the temperature. If we talk about its advantage, then thermistors, they are compact, rigged and inexpensive. They are very small in size, so they are compact and inexpensive, and they can bear any types of shocks and vibrations and environmental conditions, so they are rigid materials. Also, they are having good stability, highly sensitive, their response time is fast, not affected by environmental conditions. So due to all these advantages of the thermistors, they are more preferred over the other temperature detectors like resistance temperature detector RTD and the thermocouples. Okay. So in this video we studied about the thermistors, which are a special type of resistors known as the thermal resistors. We studied its principle of working, its constructions, that in what type of shapes the thermistors comes. Then we saw the characteristics of the thermistors and then its applications and advantages and disadvantages. So I hope that this topic is now clear to you. Thank you.